So, hello and welcome to today's stream. As you can see, I have changed this photo frame and added this border of greenish color. Also, I missed my Wednesday stream, and today is Friday. So I decided to do stream on alternate days on Monday, Wednesday, and Friday. But I was not able to do the Wednesday stream because I woke up late. Also, in last stream, I was doing a question which I was unable to submit successfully on the stream. Mm, I think this was the question. Whether on Monday, this one on Tuesday, Wednesday, Thursday. Okay. Yeah, this was the question. So the idea was same, main idea was and approach was same which I used in my stream. Just a little bit of change in the approach was that just a change was that earlier I was grouping two. Let me show it. In the streams code and solution, I was grouping two positive deltas with a negative delta, but it is not optimal to group such to form a group of three people. We should always form a group of two positive deltas, or we should form a group of one negative delta and one positive delta where positive delta is greater than equal to negative delta. Because if we form the group of three, then our next negative delta will be a more smaller value, meaning more in negative side. So it will be expensive, and we will not be able to group it uh, with a smaller delta. Suppose here we have a smaller delta, so we will not be able to form the groups. So there is a greedy idea in this, and this was the change in my code, and I submitted it within 5 minutes of ending the stream. Hmm. Earlier we were forming groups like this, but this is not correct. We have to form this and this negative with this 2 because 2 is greater than minus mod minus 1. Let's see today's question now. So let's create the page. 51, 1200 problems. What's the name of the problem? Storage. Let's read. Once upon a time, Mike and Mike decided to come up with an outstanding problem for the some stage of or a rare Olympiad. One of them came up with a problem prototype, but another stole the idea and proposed that problem for another stage for the same Olympiad. Since then, the first Mike has been waiting for an opportunity to propose the original idea for some other contest. You are given array A of an integer Q queries. Okay. Replace the ith element in the array with integer x. Replace each element in array with integer x. Sum of all the elements in the query. We will have to form. The question is less wordy and straightforward in explaining what we have to do. So the situation is like this: we are given array A length n, and we are given Q queries, and there are two types of query. First type is we replace AI with x, where here it is given. This is the case when t is equal to 1. T is equal to 1, I x given. Second case is we replace all AI, where all is important. All AI with 1 is equal to x. This is case when t is equal to 2 and x is given. So we have to print sum after each query. The constraints we are given n and q, and AI is integer t. T tells which of the operation we perform in the query. Okay. Let's So AI is in integer range of n solutions will work, n log n will work fine. Oh, mm, q log q, there will be, I think the solution, the final solution which we will make will should have, because we will have to no matter what iterate over all the queries. So q factor from there, and we should update employ a method such that the updation and the sum is calculated within log n time. So we'll have to figure this out. So let's see now the approach, what we can think from this given information. This is the array 1 2 3 4 5. If we calculate our initial sum before any query, then the sum will be, sum is then, what is the sum of first 10 natural numbers? 5 into 6 upon 350. Okay, this we can calculate. We will calculate this first time only before the first query. So this one should take O of n. Okay. Now the first query tells us that we change the first element by 5. If we change the first element by 5, this is one base index. Code forces use one base indexing. First element by 5. So we will first have to subtract this 1 is changed into 5. So first we will have to subtract the original element from the sum, which is 1, and then plus 5 from that. And how we will tell this is 1 here, we can look up to a of I without change. First sum minus equal to a of I, then we will set a of I is equal to 5, and then we will do sum plus equal to a of I. So 15 minus 1 14, then this is updated to 5. 14 plus 5 is equal to 19. So good. And here we cut it and change to 5. Okay. Okay, we are performing this updation here. Okay. the first query, query 1. Now for the second query, we have 1 5 3 4 5, the updated array. The second query also is of type second type, where all the elements are replaced. So sum is easy in this case. If all the elements are changed, and total there are 5 elements, and all 5 are turned into 10, then the final sum will be n into the x which is given here, which is 5 into 10, this is 50. So it is easy to update sum here. But the problem is, if we now try to change all the elements here and turn them into 50, then that will take O of n updation. For we are already doing this inside a loop which is q for each query. So this should take order of q time. This will run q times, and in the updation of first kind of operations, that is a constant operation because we are given the location and the new value. So we are able to do the first operation in constant time of 1. Hmm. Okay. Then we can also calculate sum easily in the query of second type because all the elements are replaced. But if we have to actually replace all the elements, then that will take of n. So that will can lead to of n into q. And this can be a brute force solution till here, but we will have to figure out the way and avoid this updation. Hmm. Now the third query is first type. First type of query where we change the fifth element. Fifth element is changed to 11. So for performing this query, we first have to see which type of element we have in first place one at the fifth position, and if we have not updated it here in this step, then this will lead to an incorrect earlier solution, earlier value, because we didn't perform the updation here, because it will take off n, and it should be 10 but it is 5 at the moment. So we have to figure this out. You cannot iterate over all the values. Cannot sort them because it will disturb the ordering. So how should we perform the updates? Some 50 minus 10, the update should be looking like this: 50 minus 10 plus 11. Hmm. Ideally, our array at this moment before performing this query should look like this. Hmm. We have to update the fifth element. This one. Sorry. And 10. It looks like all 10. Hmm. Hmm. We need to perform the updates in some manner so that we can tell that okay, we have all 10 here. I'm back in one moment. How should I update it? Usually, what I have seen in these query questions, people use segment 3, but I have not studied it. Also, I think this is a 1200 rated problem, so there should be a way without segment trees. Second type of query, second type. What we can do is What we can do is, but one thing I thought was, if there are q queries in total and some queries are of second type, this will update all values to 10. So for each query of second type, here 2 in this case, there are 2 queries of second type. I will store the vector of vector the first when there when the this query before executing or processing this query, we have array in this state 1 2 3 4 5, and when we process this query, then the array will look like this 5 times 10, and when this query will execute, then it will look like this. So what we can do is, we can initially have our I here set to initial state, then we do all the updations and all thing for the first query, and when we reach that second query, we increment this I. So now our I is here. Then we perform the second query on this array in constant time, and also on this part in constant time. Then we again encounter the query of second type, and we increment our I, and we tell the sum. But the catch in this is, if all the queries are of second type, then this will again lead to of q into n. So this is also not feasible here, and we should look something in the lines of q into log n. In log n updation, which structure has log n updation for the entire part? If we declare a new vector of, if we make a new vector and substitute it with, but making a new vector is of all the same elements, should also be of n in C++. We need to keep track of the array because we are updating in first query like this. Or we can tell what how much to add or subtract from the final sum. Hmm, We have to perform many updations at once. Let's ask data structure suitable performing many updations at once. Range updates and queries Fenwick trees, segment trees. If I see on a hint, what if we happens a query of type 2 changes all element to the same value x simultaneously? We lead to the sum n into x and it leads to time limit because we cannot update it of n if we choose a vector. Okay, second hint. Keep track of the last global update for type 1 queries if that element was last touched before the global update. Treat its current value as global value. Okay. Global value. If we maintain a global value for type 1 queries if that element was last touched before the global update, but it was only touched for a specific index. So how can we figure it out? Because if the query next query comes for another index of type 1, then the global value will contain, according to this hint, the value of the updated element of a particular index. But we have a global the we are performing the new operation of type 1 at a new index which has not been updated after the second query. So but global will contain a value which was updated after the query of second time. So what is global time here? Hmm, I think for the moment we should code the brute force, then see what we can come up in this time. I usually struggle with the query type problems. Um, we have N and Q. Okay. We should take the input. Now we perform the Q queries, and we should also calculate the sum beforehand. Long sum, sum plus equal to. We should see what type of query it is first. Ft equal 1 else it is query of second type. So first we take the index, index, then we take int x, cnx, then we update, perform the update for first query, first type of query. Here we should change all the elements that will take off n, which is the bottleneck. What we can do, this will lead to something, but still this is O of n vector n b. vector copying and vector initialization should take off. And we update a is equal to b, and the sum is updated sum is o for each query. Okay, you have to tell the sum at that moment for each query. Okay. Because if we had to return the sum, final sum after performing all the queries, then that is easy, because we can track the last time there was a query of second type and then perform the updations. Okay. Sum equal to banana and star x, and after performing each query we print the sum. This is a solution of complexity q into n. And this should lead to TLE. Should have one base indexing. Let's abandon for the sake of completeness, because I have not any idea at this moment how to optimize this and use this hint of global update, global value. Because if we have a global value, and if we only update perform a query of first type on a particular index, then at the other indexes the old global value is still present, but on the new index it is a different global value, but it is telling us to keep track of last global update for each index or for all. Let's submit this. Time limit on second test. All values are changed after this. Okay. So we can keep track if we want to know the value. We are sure that there will be 10 at that place. You may visit and but I can think from the global value thing is I will have to reset it here. Okay. What we can have is something can use a map. Can use a map. Mm, if we clear the map, time complexity for clearing a map. K of n. Okay, so this also fails. Because if we perform a query, this is on 4 index and again on 5th index, something like 9, then we need to use this value in here. Okay. And if on the other hand we have something like this 1 3 6, then we will have to use this 10 because 3 has not been updated after the global update. So how to keep track which indexes have been updated after the global update? I thought that we can make a map and we can clear it when we reach a global update state and update it here. Map 5 is equal to 11, something like this. So for future index, first I will check with map whether it is present or not, and then we can update with 5 if 5 occurs with this value. We will first check it with map. Similarly, we will check with 4, but we will not find. Then we make a new entry after this update before the 1. For 3, we didn't find this value in the map. So we use the global value and then we update the 3 also. But this is still slow. This is due to the clear step in the global. If there are two types of operations and one is expensive and one is cheap, then there are many operations, cheap operations plus expensive operations. Then according to amortized analysis, the cheap ones will compensate for the expensive ones. Something like this I have read. But if there are many expensive operations, then they will not be able to compensate with the available cheap ones. I'm not getting any idea. I think I should end the stream because I am out of ideas at this point, and I think I will surely learn something from this problem. And I always struggle with the query type of problems. If I look at the CPH, difference area. We focus on operations that increase all elements by x. 3 minus 2. Think I should study about difference arrays for this question. But if we have a x, we need to fix it to x not increase. We need to form the range updates. Hmm. How much we should increase each value? If we calculate that, that will itself take linear time. Okay, I think I will end the stream and I will be back on Monday. I will be back on Monday with Monday or Sunday, I think on one of the days, and I will discuss the optimized solution for this problem. We implemented the brute force which takes off n into q, but ideally we should be looking at a solution which take this much time. And the main bottleneck in this question is, for my brute force approach, doing this array update, not the sum update. This array update to keep the track of latest values which are present in the array. And why should we care about updating this array? Because ultimately we need the sum. That is because to calculate the array for first type of operations, we need to see what we have present in our array to subtract it initially and then add the new value. Therefore, we need to perform the updates on this array. And this is the main summary of today's stream. Now I am calling it a day. Okay.